On the back side of your notes, we have a couple of new skills and concepts that we want you to pick up from this second day of solving equations. And the first new skill is learning how to clear fractions that are in an equation. Now, you might think that, well, I have Desmos, and so I would just be able to work with fractions in Desmos. And that is true on a problem like this. If you had 3/4 x minus 4 equals 5 over 6, you can just use Desmos to solve that equation. And that's because we only see this variable one time, and so it's a little bit easier for us to deal with. But sometimes you're going to have equations where the variable is written twice. It's on both sides of the equal sign, like we have in this problem. And it would be helpful to know how to clear out those fractions. So this skill involves being able to find the least common denominator. And actually, it would actually be okay if you just found a common denominator. So we're going to take a look at the two denominators that we have. We have a 5, we have a 2, and we can multiply those two denominators together to get 10, and that does happen to be the least common denominator for this problem. Now, this process or skill of clearing fractions is accomplished in this step, where you multiply all the terms on both sides of the equal sign by the least common denominator. So I'm going to write that as my least common denominator, 10 over 1. I'm going to make it a fraction. And then I'm going to write my original problem. I'm going to take 10 over 1 times each term of that original problem. So first of all, I'll take it times the a over 5. And then I have a plus sign in my original problem. Now I'm going to take my common denominator, which was 10. This time I'm multiplying it by 3, so I'm not going to write it as a fraction. Then I have my equal sign. And once again, I'll be taking my common denominator. It's going to be multiplied by a fraction this time, so I'm going to write it 10 over 1. And then my other, or the last part of my equation, a over 2. So if you'll look, written in black on the this line is really my original problem, and written in red is my common denominator being multiplied by each term. So then I am going to simplify. Now, when you simplify with common denominator, or with your least common denominator, we really want you to pay attention to the fact that you can cancel diagonally. So 5 will divide into itself once. 5 will divide into 10 twice. And since we have the numerator now as 2 times a and the denominator as 1 times 1, we don't need to write the 1. In fact, that's why we're doing this. We want to not have to write this as a fraction. So we'll just take the 2 times the a, and that will be my first term. Then we have your plus sign, and then 10 times 3. Now that's just regular multiplication. 10 times 3 is 30. Then we have your equal sign, and we can do some cancellation again. So 2 will divide into itself once. 2 will divide into 10 5 times, and now we have 5a. All right, so we have 2a plus 30 equals 5a. Now, on the front side of your notes, I talked to you about looking for where you have a variable on each side of the equal sign, and how I like to get the variable to the left side if I can. Here is a situation where that is not really a great idea, because if I subtract or zero out this 5a, then my right-hand side of the equation will just have 0 on it, and that often gets confusing for students. So here's a case where I will want to subtract the 2a and get my variable, this time on the right-hand side of the equal sign. So in other words, I don't want to completely cancel out one side of an equal sign. So the 2a and the negative 2a will cancel. I'll bring down my 30, it's positive, and then my equal sign, and 5a minus 2a is 3a. And then I have my last step. I can divide both sides by 3, and 30 divided by 3 gives me 10, and then my 3's will cancel, and I'll have 10 equals a, or if you want to turn it around, you can, to a equals 10. All right, and that's the skill of clearing out fractions. If you'll look at the bottom example, we have a new concept that we would like for you to know about. Sometimes when you solve equations, there is something unusual that happens, and the result is that you either get an equation that has no solution or an equation that has infinitely many solutions. So your first statement there, if a variable, if all the variables cancel when solving the equation, and the remaining statement is true, something like this: 0 equals 0, or 5 equals 5, then the equation has infinitely many solutions. And something else could happen, so that part B, if all the variables cancel when you're solving the equation and the remaining equation is false, then the equation has no solution. And so I'm going to show you these last two examples so that you can see that happening. So this first problem, I have parentheses, so I'll remove my parentheses on that left-hand side of the equal sign, and I'm going to go ahead and do the separator. So 3 times x would be 3x plus, and then 3 times 4, and that gives me 12. And then I have my equal sign, and then I have 3x plus 12. So if I follow along and do what I've been doing, I like to get that variable on the left if I can. So I'm going to subtract 3x from both sides of the separator. And maybe some of you have already noticed something unusual about this problem, but I'll continue on. So 3x minus 3x cancels, and I'm left with 12 and my equal sign. But I get to this side, and this is actually the side I was thinking would cancel. Those cancel because I have 3x minus 3x, and so all I'm left with is 12. So notice that all the variables canceled when I was solving this, and I have a true statement. Since I have a true statement, the solution to this is infinitely many solutions. And this is the terminology that Alex uses. You might also see it as all real numbers. So it's also the case that you may see it as all real numbers. So that's 5a. If we look at your problem 5B, you have parentheses once again, so we will use the distributive to remove them. So 3 times negative 2, that's negative 6. And then 3 times negative 3x, that's negative 9x. Then you have your equal sign, and then negative 9x minus 4. So I have the separator right here. I want to work to get my variable on the left-hand side. So I will add 9x to zero it out on both sides of the equal sign. So I'll bring down, I have my negative 6 and my negative 9x and positive 9x cancel out. I'll have my equal sign. And then again, it happens. The negative 9x and the positive 9x cancel out. But I still have something on that right-hand side of the equal sign. I have a negative 4. Only this time, I have a false statement. Negative 6 does not equal negative 4. So that statement is false. And when all the variables drop out or cancel out, and you get a false statement, then you have an answer of no solution. So this will be the end of your notes on solving multi-step equations at a little bit higher level. Remember to be very careful writing down your problems. Check to make sure that you're carrying through negative signs. And if you make a mistake, try not to get frustrated. Look to see if you can find it quickly. And sometimes it just helps to erase it and start over. So we don't have very many problems for you. Good luck, and be sure to ask questions.